Hello all, this is Priyadashini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to continue with the same lecture series on loss function. So in the previous video itself I told you what is loss function. Just to recap, loss function is nothing but it is a mathematical function that helps to quantify the error. That is, it predicts the difference between the actual output and the predicted outputs, model's predicted output. So this loss function, in the previous video we have seen what is loss function, the mathematical thing, and the different types like binary cross entropy, and also we have seen what is mean square error. In this video we will continue with the next things. So as I told you, in a network model like CNN, or if it is you take RNN, it sometimes gives the wrong prediction even after so much vigorous training. And how does the model understand how wrong it is? So to answer these questions, loss function is the answer. So it measures the error between the predicted and the actual output. So the next thing we are going to see is about categorical cross entropy. So as I told you, the categorical cross entropy is used for multi-class classification. So out of several possibilities, it predicts the correct output. So the formula to the categorical loss is L is given by minus of your sigma f yi into log pi. So this categorical cross entropy loss is the most commonly used loss functions in CNN. It is used with softmax activation. So this is how your categorical cross entropy loss works for different types of classes. Different type of predicted possibilities will be given. So the examples include for categorical cross entropy would be for digit classification, or if it is handwritten digit recognition. For all these things we can use your categorical cross entropy loss. So the next thing about the loss function is sparse entropy, or the sparse categorical entropy loss is the next type. So it is similar to that of categorical cross entropy, but the difference is that it is used when labels are used instead of one-hot encoders. So it is mainly used in dataset labels like 0, 1, 2, 3. So for these type of classification models, then the sparse categorical cross entropy loss function can be used when the labels are integers instead of one-hot encoding vectors. Now let's see how these loss functions works during training. So as we all know, convolution neural networks takes the input as a image. So here we are going to send a cat image in the CNN for training. So input image will be passed into your CNN network model. So the cat is being passed through the network model. Now the predicted generated output would be given by CNN. When you give the cat image, the train model should understand and it should predict the output as cat. But if the predicted model is, that is, if the predicted output is dog, then it is an error. So then the loss function, what is the next step is loss function. So the loss function here, the computes error. Since we have passed the cat as an image, but the model predicted the output as dog. So there is an error. So this error is being computed. The measure between the actual output and the predicted output is the loss function. So the loss function has been computed for the output we have got. The next step, what is in the training, is it computes the gradients. So the back propagation is used to compute the gradients by adjusting different weights. So this back propagation and this thing will be given in number of epochs. So as we all know, epochs is nothing but the different times the input is being given and output is checked. So the loss will be reduced after so many epochs. Like for example, we can have the epochs to be 20. So this is how the loss function works during the training. Let's see the applications of this thing. So the first thing is the CNN model is mainly used in your medical imaging, such as to detect the cancer cells. The loss function misses the prediction error then the lower loss will be having an accurate diagnosis. If it is a higher error, then the diagnosis is not accurate. So for a medical imaging, the best thing is CNN. The next one is in autonomous vehicles. If the CNN detects pedestrians walking, then if it is incorrect detection, there will be a high loss. Imagine the high loss, and the training minimizes the loss for safer driving in autonomous vehicles. Let's see the challenges available. So if it is wrong loss, that is if the loss error is too much, then the model performance is very poor. It is mainly sensitive to outliers. If there is imbalanced data sets, can lead to imbalanced mislead loss values. So choosing incorrect loss will slow the convergence. So we have to be very careful in choosing the right model. So to conclude, loss function, it guides the model learning. They connect prediction errors to weights updates. Choosing the right loss improves the accuracy, stability, and the convergence of the model. In simpler terms, loss function is the teacher that tells how the model worked and what has acquired in the training and how wrong it is and how to improve. These all will be answered by the loss function. Thank you.